Is automation really rocket science? Or is automation so simple to actually implement within your manufacturing line? Thank you so much for tuning in this morning. Thank you so much for actually making time this morning as well to listen to what we have to share. And we hope by the end of this morning session, you'll be inspired by what Mr. Eddie Fong from Platform, of what he actually implemented in his manufacturing line. And we hope that you'll be able to also take this opportunity and move forward and actually take up this challenge, and of course maybe implement a smart factory within your manufacturing lines. So this morning will be very interesting, right? So we're in the middle of the welcoming remarks, all right? And after that we'll introduce Mr. Eddie, who will share his successes in going smart, and later on we have Teh Tarik with Dr. Chua. All right. And then of course when the Teh Tarik ends, then we have an Ask Me Anything session. It's something like a Q&A, right? Now, let me first introduce to you who Mr. Eddie Fong is. Now, Mr. Eddie Fong, he possesses a mechanical engineering degree from Monash University and is a graduate diploma in business administration from Swinburne University. He has been in the plastics industry for the past 43 years and specializes in injection molding of engineering plastics. Since joining the Malaysian Plastic Manufacturers Association, MPMA, he has been very active in the areas of organizing international plastic conferences, championing skills, upgrading via TVET, industry academia collaboration, and technology upgrading for the Malaysian plastics industry. He is the current Secretary General of MPMA, Chairman of both the Plastics Technical Training Center and the Talent Development Program. His passion is to see the Malaysian plastics industry upgrading itself to be able to keep up with the skills requirements alongside the constant introduction of new technologies and to be competitive in the global arena. Please welcome Mr. Eddie Fong from Platform.
Thank you, Kenneth, for the kind remarks. Let me introduce you to Platform a little bit. Platform was formed in 1991 when I came back from Malaysia. I came back to Malaysia in 1986 actually, but I was helping my brother develop his ice cream business, believe it or not. That was a year of recession where, 1986, sorry, not 1996, 1986, oh, time flies. And I was developing his ice cream business. Money was hard to come by, so we approached a lot of banks, and to cut a long story short, finally we got some money to expand the business, and the business has since quadrupled in the 6 years that I was helping him. Then I decided that, okay, 1991, it was time to start Platform, because a lot of the stuff that I learned from Australia, 8 years in the industry in Australia, was very relevant. Not only relevant, was about probably 10, 15 years ahead of its time compared to some companies, the average company in Malaysia. So that's how Platform started. So what's our vision for Platform? We want to be among the top injection molders in Malaysia. Please note that carefully, not the top, but among the top. So there's a difference there. So being the top, very hard, I think. Be among the top is slightly easier, but still very hard. I shall explain why later on. So our mission is to grow profitably, of course, to produce a satisfied customer by supplying quality products that give good value. This is the emphasis there, good value. Giving excellent service that exceeds customer requirements, not expectation, customer requirements. We know their requirements, we want to exceed that. But expectations, sometimes they always expect sky-high things, so we cannot fulfill the expectation sometimes. Doing better than our competitors, I think that's, it's not just being kiasu, but also being better means like you want to do a little bit better than your competitor to maintain your cutting edge. What are our values? As a Christian, I believe that everything we do, we should honor God, So the other value is to value and develop each employee. And this is where Platform spends a lot of time training our employees, whether they are operators, technicians, managers, and so on. I still get very hands-on in this. I still give lectures in the company, to our new technicians that come in, our QC people, and so on, to bring them up to date with the latest knowledge of what I have. To treat each person with dignity, I think that's very important. I was talking to Kenneth just now. Today is our company trip day to PD. because the workers have been complaining, boss, we've been locked down for 2 years, cannot go anywhere. So we decided, okay, I'll go to PD for an overnight trip. They're very, very happy. So I'll join them later. They're on the bus now on the way there. So one of the reasons is to actually build the comradeship among the workers, build comradeship not among their own group, but cross groups like the QC and production, always allocate each other. QC and the engineering, and engineering and production and so on and so on. So the building that comradeship is very important. Treat each other nice, We have a new platform culture, which I won't share here, but one of the things is to have a joy at work, and respect each other and so on. So there's a lot to say about that, but we'll leave it for another day. Then to act with integrity, I think this is very important, yeah. So that's platform and the gist, what we believe in, what we want to work for, and so on. So this is a factory layout of the 2 production floors. We are in 4 terrace factories in Kajang. As you can see, there are about 6 machines in one place and another 8 in another. These are the smaller machines. We have 8 of them lined up like this. 6, 1, 2, 3, 4, 5, 6 here. So we have 14 machines altogether, and we have about 40 people in the workforce. Talking about I 4.0, everybody wants to talk about I 4.0, the government pushing I 4.0 like mad. But what is really I 4.0? They come up with these 9 elements. So if you try to do all 9 elements, you're bound to fail because it's too onerous. So at Platform, what we decided to do is tackle some of the elements, start small, but tackle some of them. Robotics, I think we've gone into robotics the 1987, second year we started, we bought simple pick and place robots, pneumatic driven and so on, but that's gone into more sophisticated robots, fully programmable servo Cartesian robots, and now we have bought some cobots, which are collaborative robots. Simulation, we've done a bit of that, but very seldom. I think when customer demand to have a perfect product, so we do a bit of mold flow. In fact, I was a mold flow guinea pig back in 1979 in Australia. We went to the founder's house to do all the programming and so on. So that's another story for another day. System integration, yes, you want to integrate, but try to do the basic things first, I think. So the Internet of Things, we are doing that. All our machines now are connected to Wi-Fi and so on, so they can transmit data to a central processor so that I'll show you a bit of that later. Cybersecurity, not so important for a little company like us, If you want to hack lah, what the heck. Cloud computing, I think sometimes is overemphasized. You don't have to always have cloud computing. If you are a guy traveling between 11 countries, you're always on the move, you still want to see what's going on in your plant, maybe you might want to use cloud computing. But if you're just stationed in 1 or 2 venues, I think your own internal server would be more than adequate. Additive manufacturing, we dabble into that. If a client wants to see a physical part in his hand, we go and get a 3D printer to print it, not on our own, but outside people. Augmented reality, I think that's some years away for platform. I don't think it is a necessity. Big data, yes, we are collecting data to, sort of being able to collect data, then analyze it and so on. You'll see an example of this later. So the most important thing, I think, before you start to do all these things is think about, why you want to do it. Okay, what triggered platform, to do some of the process improvement, to automate and to start I 4.0. I got 10 reasons for that, and this might be common to most of you also. Difficulty in getting foreign workers and local workers also, Local workers are even harder now because of Grab lah, Panda, Food lah, and so on, Difficulty in scheduling and delivery due to absenteeism among local workers. You want to schedule 3 machines to run for 1 client, and 3, 4 operators don't turn up that day. Habis, you have to postpone your schedule. Inconsistencies in the manual process. If you cut a gate or trim a part, using an operator, in the morning shift, it's okay. Afternoon, night shift, then you've got problems, things like that. Rejects caused by handling in the manual process. The more you handle a part, the more rejects you create. Especially some of our parts are mirror finish, you know. So if you scratch it, you know, one tiny scratch, the whole batch gets rejected, and you sort 20,000 pieces is very, very painful. To reduce WIP, because if you automate it and, you know, make a complete production cell out of it, if you like, then you have less WIP. Wages rising fast, you know, not too long to go. I think we will definitely hit minimum wage of 1,500. At the moment, it's 1,002. You see, when it's 600 ringgit minimum wage, there's no incentive to automate, right? You can employ 10 workers and, you know, it's only 6,000 a month. But now each worker is worth at least 1,005, you know, minimum wage doesn't bring you workers. So plus the overtime and so on, you'll be paying about 2,005 minimum per worker, you know, per month. So then it makes the ROI a little bit more attractive. But if you go to 1,500 minimum wage, then you have to pay 1,800 for your workers to come in. Then it's even a little bit more attractive, you know, for your ROI. Reduce boredom of operators. Yeah, I think if the guy has to sit at the machine for 60 seconds to wait for the next part to come, he will get bored, she will get bored. So to retain workers better, you better automate, you know, reduce the boredom in the plant. Increase productivity, of course, by downsizing the workforce. If you use automation, then, you know, robots don't get moody, you know, they don't get sick. They do need maintenance, but that's like fine, few in between. The uncles don't pass away, the aunties don't get sick, the babies don't get sick, they don't need, you know, sick leave, annual leave and all that. They just work 7 days a week, you know, most of them. So monitoring the productivity is very important. You want to know how many % of your machines are being used every day, and out of that machine, you know, how many % of the time it is actually running, rather than, you know, stopping, changing mold, you know, heating up the mold and all that. So if you have the data, then you can actually monitor that. I'll show you an example of that. Then the other thing is to need to upskill the technical staff. I think with introduction of new technology, you really need to upskill your staff. And the only way to do it is to get all this new technology into your plant. Otherwise, you talk about theory, go to seminar and all that, it just won't work for you, is it? But before you start on all these things, I think one of the basic things you must start with is lean thinking, you know. You heard about lean, you know, from 25, 30 years ago, 40 years ago, you know, the Japanese started this, and then the Western people also pushed this very hard. But sad to say, a lot of Malaysian factories are still not thinking lean enough, you know. What is lean? Lean is a set of concepts, principles, and tools used to create and deliver the most value from your customer's perspective, while consuming the less resources and fully utilizing the knowledge and skills and the equipment. So fully utilizing the knowledge and skills of your people and the equipment that you have. I think I should add that in. Things to consider before you embark on, you know, all this I4.0 stuff and in adopting all this expensive technology. Number one is financial requirement. Do you have the financial resources? And if not, if you need to borrow, can you borrow? How much can you borrow? Do you go and buy 10, you know, automatic piece of equipment one time, or you start with maybe 2? If 10 is very nice, you have the whole factory set up all automated, but then financially it might kill you, you know, because the repayment per month is 45,000 a month. Then for a small SME like Platform, we certainly cannot afford that. So we start small. Instead of, you know, fitting, you know, 10, what do you call it, cobots, you know, all in the factory to do everything automatically, we buy 1 first, and then 2, and then more, you know. Talent requirements. Have you got enough talents internally? If you are using 25-year-old machines and you've been hand cutting your gates and so on, when you go to automate, you need somebody else who know how to set the robots and so on, right? You know, if you're collecting data, you know, you have to find the right terminals to tap the signal from and so on. So have you got these people, you know, in place? If you don't have, then you might consider externally using what we call a system integrator. A good system integrator is a gem, you know. If you find one, don't let him go. Work with him for the next 5 years, you know, because they are also very hard to come by. The good ones anyway, you know. Tell you a story. When we bought the first cobot, we bought a very expensive cobot called a UR, Universal Robot. What is a cobot? Okay, so for some of you who don't know what's the difference between a robot and a cobot, C-O-B-O-T, is this. A robot is when you set it up, you know, it will go from A, B, C, D and do A, B, C, D, E, F, G or whatever it is. And because it doesn't understand that people can be hurt, so the robot will just move whatever that's in the way. So if the operator gets in the way, sorry for the operator, he gets knocked over, you know. Either the operator breaks or the robot breaks. But a cobot is different. A cobot is what we call a collaborative robot. It is safe for the cobot to work among people because it's got sensors in the axes, the joints. So it's got force sensors and also torque sensors that detect if it hits something, you know, above a certain setting like 2 kilogram or 5 kilogram or 10 kilogram, the thing will stop and it won't move anymore. And it raises the alarm, then you can actually see what knocked it or what it did knock, you know. So it's safe to work with a cobot beside you. But for an industrial robot, you have to put guarding around it and so on, which takes up a lot of space. So if your factory is small and don't have a lot of room, then maybe you should think about a cobot rather than wasting all the space, you know, putting guards and fences around it. So the other thing is training. You know, you might have to send your people for training in order to, you know, understand these new technologies. For example, the system integrator that worked with us, he also worked with a cobot supply company. So we had a cobot supply company, people coming to train us. But we also hired actually a mechatronics engineer before that in anticipation that we will need that kind of technical skill. For me to learn it, it will take another 5 years. So for the mechatronics engineer to learn it is 3 weeks. So you pay a bit more, you achieve your goals a bit faster. Yeah. Okay, acceptance by the existing stuff. You might have to change mindsets, you know, before you embark on this automation I4.0. Platform, we've been doing that for the last, I don't know, 6, 7, 8, 10 years, constantly reminding our people that if we keep on doing the same things that we do now, in 5 years' time, we might be out of business, you know. So this is the phrase I always use, like, you know, whether I'm in platform or in MPMA. If we continue to do the things that we're doing now, 5 years later, we might be out of business, okay? So you have to change their mindset. You let them think, oh, now we've got these things. It's not threatening their jobs, you know, it's going to make them even, how shall I say, higher pay, you know, because of productivity and so on. But they have to learn something new also and accept it. Then you talk about buy-in, then you have to wash their brain so that they buy in. If they don't cooperate with you, you can buy all the most expensive equipment. It'll be just a white elephant sitting there in the corner 2 months later, 3 months later, half a year later. Yeah. So then the pace of implementation is important. Can you pull it off in a short time, you know, or can you pull it off at all, you know? So don't do too many things, you know, don't do 10 things at one time, do 2 at a time, you know, get the 2 things done, have a success story, have something to show them, say, look, it worked, you know, come on guys, let's do the next thing, you know. So that's the approach I take. So when we first bought the cobot, everybody looked at me and said, wow, this boss is wasting money, 140,000 for a cobot, you know, which you can buy a Cartesian robot to do, almost, right? Almost, yeah. But then when we actually showed what the cobot can do, 6 months later, then they say, oh, boss, very good at this one, you know. So we started to buy more, even programmable servo Cartesian robots after that, and then another cobot after that. So disruption to production during implementation is also something to consider. When we first want to commission the cobot, it took about 4 days, you know, but we did a lot of preparatory work off-site, you know, off-site. The drawings, the design and all that was done off-site, not on the machine. So when the whole jig was ready, we plonk it on the machine. Sorry, that's an Australian jargon. How should I say, we plonk it is like we put it on the machine, near the machine. It took about 4 days to commission it because everybody was learning. They're learning about our machine. We are learning about their cobot, you know. And then there's a lot of adjustment. You know, how come this one cannot, this function cannot work? What happened? You know. Then we have to ask the robot supplier, hey, why this function cannot work? We think it should work. And all that took about 4 days. Then, unfortunately, the second cobot that we bought took about 2 weeks and a bit, you know. So there's a lot of disruption. That was sorry, I'm not against Chinese products. I think a lot of them are very good. But this is a Chinese cobot. But the thing is, the system integrator that we work with, because they have their own, was not so cluey and so on. So it took about 2 weeks. So the production was interrupted for nearly 2 weeks, and we were tearing our hair because that product, you know, the order increased nearly 3 times. You know, we had 3 machines running, but this one was interrupted. So we were panicky whether, you know, our customer might leave us. You know, so things like that you need to consider. Okay. Some of the things you need to do are simple, you know, automation, I4.0 is fine, but go back to your basic process, you know, learn your process well, improve your processes first. For example, I'm into injection molding. Yeah, some of the very basic things to improve the process or productivity is, number one, improve cycle time. So what can you do, you know, to improve cycle time? This is speaking, you know, as an injection molder. So improve cycle time by improving cooling. You know, if there are not enough cooling channels in the mold, drill 2 cooling channels in, you know, reduce the cycle time that way. Reduce the dwell times, or the mold opening and stopping for about, you know, 0.8 seconds. You can cut it down to 0.3. You know, you save half a second. Those dwell times of the movement of the molds, the robots, and so on. Eject the parts hotter, you know, when it's possible, of course. You know, to optimize your cycles, your cooling time, because some parts can be ejected a lot hotter than others. So you don't always have to eject parts at 35 degrees C, because that will take a long time to cool the parts down. Yeah, I will show you in an example later how we did that. Optimize your mold movements. You know, instead of closing at 50% speed, you know, but most of the time, the long stroke can close at 85% speed, and then when it comes to near the clamping position, then you can slow it right down, you know, to have the mold protection working and so on. This is injection molding jargon. Modify your molds to run on auto degate, and I shall show you an example of that. Optimize other molding parameters, like even decrease the temperature of the melt, you know, that will save you some cycle time improvement. Okay, this is an example where we automated the degating. This is on the left. Can you see the arrow? Can you see the arrow on the screen? Can you see my arrow on the screen? Yeah, okay. So here you see the edge gates. Okay, these are edge gates. This mold is I don't know, 18 years old. You know, when it was new, we kind of thought, okay lah. The minimum wage was about 600 at time, 550, you know, so you put an operator, cut it like, you know. So as the production volume increased, we said, you cannot afford to, you know, waste the operator just cutting gates like that, you know. So what we did was we changed it to what we call an elephant gate, a banana gate, a bullhorn gate, depending on which school you come from. Those are the 3 names for this type of gate. So when the mold, it's like a sub gate, but it's a peculiar shape like a bullhorn, you know. So okay, so now the part can eject with the gate severed, cut already, you know. So all you got to do is pick up the runner, and then with the robot, and then throw it into the crusher to, you know, do your online crushing . So that way you save an operator, you know, spending the whole day pulling all these 4 gates apart. Yeah. So that's you know, process improvement. You know, automatic the gate. This one is a picture on how to reduce cycle time. See, we bought, okay, to do this, you have to buy a very expensive thermal imager. This is an infrared thermal imager. It actually can take a shot of the molding as it comes out of the machine. It will tell you exactly what the highest temperature is. If you look at this thing, it says the highest temperature at this point is 74.92 degrees. I don't know whether the second decimal is required, but never mind. It tells you that. So the sprue is not the hottest part even, you know, this part of the molding is the hottest part, believe it or not. So, and the mold temperature here is 32 degrees. This was running at 65-second cycle, cooling time 45 seconds. Because my operator, my supervisor touched the part and said, wow, boss, still very hot, you know. But I said, okay, man, still very hot. it's not distorting, right? It's to tolerance, right? Everything is dimensionally okay, appearance okay. Yeah, still okay. So I said, I will challenge you. I said, eject it a lot hotter. He said, how? Cut the cooling time. I said, he said, how? Why? How? Then the part will distort. I said, you do first lah, then you see lah, you know. So we actually finally brought down the cooling time down to 31 seconds. The cycle from 65 became 51.45. Again, don't know how we get the 0.45. So, but you see the temperature then was rising in the part, 89 degrees. But this is a polycarbonate part, so it can eject at 92 degrees sometimes quite happily. No problems with distortion and so on. And the mold is now a lot hotter. From 32 is now 37 degrees. You know, the sprue also got a bit hotter, but no problem. Sprue got hotter, who cares? You know, as long as the part is good, it's good lah. So the exit temperature now, instead of 74 degrees, become 89 degrees. So, but because you can do that, your cycle time is improved by 21%. Okay, so something like that lah. But you have to invest lah in this technology lah. 18,000 ringgit for the thermal imager is a lot of money for a small SME. But we say that if we do it for every job in the plant, your payback will be 6 months or less. You know, so we invested in that about 2 years ago lah. Modes of automation using equipment. Okay, you can go to automation at the next stage of productivity improvement. What can you use? Things like synchronized conveyors. I'll show you a picture and then explain how synchronized conveyors can help you. Programmable Cartesian servo robots. In the old days, we used to use pneumatic robots. Everything is pneumatic, chung, 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 chung. It can only go A, B, C, D, E. That's it, you know. But with a Cartesian robot that is servo control or programmable, you can go A, B, C, D, E, F, G, H, I, J, you know. So you can. The newer they are, the better they are. Even the Chinese robots are coming out with tremendous products, you know, that are actually as good as the Japanese one functionally or even better, but at about half the price. I'm not saying that they are better, but I'm saying that if you want to start a bit cheaper, okay, don't go and buy the most expensive unless you're very confident. I mean, I've got a Japanese robot. If I tell you the name is Yushin, you know, that they will last 22 years. The Chinese robot, I don't know how long they last, but I bought 4 of them, you know, 4, 5 of them now, you know. So, but it's half the price nearly, you know. So let's start with that lah, you know. Don't go to the most expensive lah, you know. Then programmable 6-axis robots or cobots. These are Chang'e things, you know. You can do a lot of things. You can do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, you know. With them. So you can program it infinitely almost, you know. And the path they move can be a curve, can be a ellipse, can be all sorts of paths, you know. Whereas your Cartesian is a bit more limited. And the cobots or the robots can move in a spherical space, you know. As long as it's within that spherical space, the robot can reach it. But your Cartesian might not be able to do. Robots and cobots in tandem with ancillary equipment. And I will show you an example with how we use a cobot with a vibrator bowl and so on to assemble parts. So I'll show you examples of this now. This is a synchronized conveyor. So instead of having a conveyor running continuously, you know, bringing the part to the operator who sits here and then cut the gate or pack or whatever, you can actually synchronize the conveyor to line up maybe up to 10, 15 parts, you know, depending on how big your parts are, along the conveyors. Why is that good? Because then you can have 3 conveyors in this same kind of configuration where they are lining up all the parts. So it takes maybe 10 minutes from the conveyor to get from that point to where the operator's table is. So what happens is instead of, and your process only takes maybe 30 seconds. So your operator can come back every 5 minutes, you know, to clear the conveyor and, you know, go to the next machine, clear that conveyor, go to the next machine and clear that conveyor and come back. So now you are using an operator to guard, to look after 2 or 3 machines instead of just 1 machine. And the added bonus to that is that your operator doesn't get so bored, you know, sitting there waiting 60 seconds. This is a long cycle part. So cylinder 90 seconds for this particular part, you know, because very thick, it's 3.5 mm, 4 mm, you know, polycarbonate. So therefore, you know, the operator will less board. Let me put this guy on hold. Sorry. Hey, I'm in a webinar. Cannot. I'm in a webinar. You can call me back an hour later, please. Thanks. Where were we? Okay, so your operator can jaga 2 machines or 3 machines. So you save how many percent? If you jaga 2 machines instead of 1, 50% labor saving. If you jaga 3 machines instead of 1, 60% labor saving. Very good, you know. Cartesian robot, servo Cartesian robot, in this case programmable. See what it does? Stop the part. Opposite to a cut it, throw away the runner. This is the simplest one. I'm showing you so that you know we do it and wait for the next cycle. Somebody asked me why your robot travels so slow, I say okay, if it's out of the mode already, it's on time. Going in and out must be fast. It's waiting for the mode to close and do all those things. And the long cycle means that the robot has got plenty of people. You don't need to wear your robot now. Take its time, go slowly, it's still waiting. Okay. This one is just a simple pick out gate cutting force. One cavity. This one is now the cobot from China. It's called a Dobot, D-O-B-O-T. Don't know why they call it a Dobot. It is taking out. That's what it can do. But let me show you something before. For all this automatic operation, you need to be careful because these are all machines that, you know, even though the robot has a sensor, it won't hurt anybody, but it might still crash into your mold. So you have to set up some safety. What we have here is, this machine is, I don't know, 15 years old. We're retrofitting it on a, of all brands, Haiti and the China machine. China and China, they can talk to each other. So no wars among them. So we put a light curtain here, you know, so that if the cobot or dobot is in anywhere near the mold inside, the mold will not close. Things like that. You got to put a bit of safety in it. So that one also is another thing that you have to learn, that because if you start on this without the safety, you might damage a very expensive. This is 80,000, you know, worth of equipment. Oops. Yeah. So next one is we are using this. This is a Danish a cobot, which is from Universal Robots. This is very, very, very expensive. 140,000 to set up this fellow with a bit of the jigging, but not this. This one is another, don't know, 15, 18,000. I forgot already. So what we are doing is we are trying to assemble this part, this little part here called a plug to the big cap here, the blue one. It says the test run. Yeah, so that's what you can do with a cobot lah, or a industrial robot also can do. But this one, because our space is limited, like I say, it's open. You see, you don't see a guard around it, you know, so it's safe to work with people around it. Okay, then we found that, you know, it can do so many things. So we say, why don't we try something new with this? We make it into a milling machine and see what happens. Does it work or not? So this doing milling operation. Is following a contour track into the original position. And the operator looks up the next one and, you know, it can start again. The story of this part is that we have a problem with the molding. The molding is about 30 or so microns over the thickness. Why? The technician go and pack the pressure so high that, you know, the thickness actually increased by about 30 microns. So it's 30 microns off spec. So we said, wow, you know, we throw away 6,000 pieces, 6,000 pieces is 9,000 over ringgit, you know. So we said, since we've got this the cobot, why don't we try to salvage that 9,000 ringgit, you know? So we actually bought what do you call it, a servo motor here, you know, speed control motor, make up a table, you know, for it and so on. So the whole thing costs, including the labor, 2,000 ringgit or less to actually do all the milling, do all the setup and so on. So if you do the sums right, you say 9,500 minus 2,000, you save 7,500 ringgit worth of products, you know. So that was quite a good payback, if you like, for a cheap investment into a speed control motor like this. So you can do that with sophisticated equipment. So in fact, if you really think about it, you know, you can use your imagination to do a lot more with something like a cobot. Okay, this is a vision sensor system we install on the mold to detect parts. After the mold has opened and ejected, make sure that all the parts are cleared before we clamp it again. So yeah, you saw a flash, right? About there, you I think about you see the only thing you can see is the flash there. It's now taken a picture and then compare it to the master that you set up. When you take a picture of the master, the mold is clean, you know, there's no part stuck in it. Now, this is a typical shot of the Cognex system where this part is put in there on purpose so that actually to simulate that there's a part stuck in there. So the mold doesn't close now because the sensor say that, hey, there's a part stuck in there, you know, better not close the mold. This is going to cause double clamping and damage the mold and so on. So if you've got very sensitive molds and very high precision molds, this is the way to go. Otherwise, you clamp the mold once, it's going to cost you 2,000 ringgit maybe. YA will be able to tell you that some of these high precision molds take a lot of fixing, you know. And not only that, you incur the wrath of the customer and disrupt his production for 2 weeks and so on. You know, he's not going to be very happy. So if you've got a sensor system like this, it will report to you, it said result here, fail for that particular mold. Fail means the part is stuck in the mold like this, and the detection will prevent any mold damage. You know, so that will save you money and a lot of anxiety and a lot of sleepless night. So, okay, data collection system, you know, we want to see whether the machine is running or stop. You want to compare the actual cycle to the costed cycle, calculate efficiency of the run, shows any disruption and stoppages during the run. We can add things like setup time, purging time, startup time, all into the data, so that at the end of the week or the end of the month, you can analyze it and see how your machine is performing, how your shop floor is performing. This is a typical dashboard that we took, you know, this is around the 11th of this month, earlier on. You can see that, you know, there's a machine identification here. You can see in this part, this targeted cycle is 39.5. The actual running cycle is 38.95. So this machine is running at about 102% efficiency. That tells you that the day shift has produced so many parts and the night shift has produced so many parts and so on. So if the line is straight on the top there, then there's no interruption. The machine is running fine. But look at the bottom part, machine 10, cycle is a bit over cycle, but not too bad. You know, about 4% out. No, 0.5, about 2% out. So there's some interruption here, you know, as you can see. If the line is down here, then there's interruption. The machine has stopped. So you can see during the day, about 2:15 like that, to about 3 o'clock, there's a lot of there's a long interruption here, and then start again, and then another long interruption. So you can point this bubble at anywhere along the line, and it tells you exactly when the interruption started. Then with this data, you can go and talk to your supervisor or your technician and say, hey, what happened to the machine at 2:15? You know, there was an interruption. Or then they tell you a long story lah, you know, the backpack got stuck lah, like this lah, or the material got stuck in the throat lah, didn't come down lah, or whatever, because you're using regrind and so on. But the gist of it is that you can now see, you know, whether it's running well or not. And then you can ask those questions and then find out the causes. And then from there, you can take some steps to fix those problems and get rid of them. So this is the usefulness of data collection. This is only calculating the efficiency of the machine. So you need another two variables. You need also the uptime of your machine, available time of your machine. Then the other variable you need is to see your quality yield, whether your 100% of your parts are good or 85% of your parts. So if you multiply the three, 0.9, 0.9, 0.9, for example, you get 72% efficiency. Most SMEs run at about 45 to about 55% efficiency, if that. World-class company, they're approaching about 80, I think 85. So we really want to move on to become world-class, in Malaysia. So this is the reason why we are doing all these things. I think that's about it. Sorry, I've taken a lot more time than I intend to, but I thought I'll explain a little bit more so that, we don't rush through. Thanks, Kenneth. Back to you.
Thank you, Eddie. Thank you so much, Eddie.